How come we can sometimes see the moon during the day in the sky along with the sun? Isn't it always supposed to be that the moon's out at night and the sun is out during the day? No, that's maybe what we learn in storybooks when we're kids, but we can see when we look in the sky that it happens reasonably often. So I got exclusive access to a top secret facility with amazing scientific instruments that allow us to explain how we can see the sun and the moon at the same time. Some of these really high-tech instruments are very dangerous and have to be handled very, very carefully. For example, this is a soccer ball, half covered in tin foil and half covered in black plastic. And this represents the moon. Okay? So you're only going to see the side of the moon that's lit up by the sun. Only the side that's facing the sun is going to be lit up. The side that's away from the sun is going to be in complete darkness. And this is exactly the same for the Earth. This is the side that is daytime, and this is the side that is nighttime. How do I know this? Well, we've got really good photographs to prove it. This photograph is from Voyager 1 in 1979 as it was flying off towards Jupiter and Saturn. Looking back, you can see that the Earth and the moon are both lit up by the sun to the right of the picture. And the other side is in complete darkness. This image is from the NEAR mission, or Near Earth Asteroid Rendezvous mission. And you can see we're looking at the Earth from the bottom. There's Antarctica in white and Australia. And you can see the moon as well. They're both lit from the right by the sun, and on the other side, it's nighttime in complete darkness. So as I said, I'm under strict orders to keep this location completely secret because of the top secret experiments that occur here. I'd love to tell you where it is, but I just simply can't do that. So we're here at the playground, and I'm going to use a merry-go-round and these two balls to demonstrate how the sun and the moon can be visible in the sky at the same time, and why this moon looks different at different times of the month. It takes 24 hours for the Earth to rotate on its axis. We call that a day. It takes 27.3 days, or nearly 28 days, for the moon to go around the Earth. Now the sun, or the red ball, is going to stay in the same place because that's really far away from the Earth. If I could, in this experiment, I'd be showing that the Earth, or the merry-go-round, would move 1/12 of the way around the sun, or 1 month around the sun. But it would make things very complicated. So for the sake of this experiment, we're going to pretend that the Earth is staying still and the sun is staying still. And it won't make a big difference to our experiment because we're looking at how the moon behaves. So I've put a video camera on one of the handrails, and that's as if I'm standing on the surface of the Earth, looking up at the sky and seeing the moon when it's visible, and seeing the sun if the clouds aren't in the sky. But I can definitely tell when it's daytime and when it's nighttime. So as I said, the red ball represents the sun, and if it's full colours, that means we're in daytime. If it's black and white, that means it's nighttime, or we're on the nighttime side of the Earth. So just like somebody sitting on the surface of the Earth turns anti-clockwise, and you see the sun come up on your left, or the east. The Earth keeps turning, it crosses the sky and it sets in the west, and then you're into nighttime. The Earth keeps turning anti-clockwise until you reach the sun again, and it looks like it's coming up on your left or in the east. And it's exactly the same here on the merry-go-round. As I turn around anti-clockwise, the sun is going to disappear off to the west. I'm going to go into nighttime, and then the sun is going to reappear again on my left, or the east. The sun rises in the east, it sets in the west. The same as the moon does. It rises in the east, it sets in the west. So here's our starting point. We can see the sun in the sky, but we can't see the moon. It's completely black. There's no light being reflected from it because it's facing the sun. So we can't see the moon during the daytime. Remember, we're in full colours. It's daytime, and now it's gone black and white. That means it's nighttime. The Earth keeps rotating, and we're in colours again. We can see that we're in daytime. And you can see the sun would appear from our left, or the east, and move towards the west. And here we can see the sun and the moon at the same time. The sun and the moon have moved further apart, and there's a tiny little sliver of silver on the right. And that's the side of the moon that is facing the sun. And we're beginning to be able to see a tiny little bit of it now. So if we're looking up at the sky, It's all colours, so it's daytime. We can see the sun and we can see a little sliver of the moon. So it's turned black and white again. So remember, that's nighttime. And the moon is in the daytime side of the earth. So it's a lovely dark night and good for watching stars. We're in full colour again. That means it's daytime. So we can see the sun and the moon have moved even farther apart. And now we can really start to see more of the moon's daytime side. So we're seeing the sun and the moon at the same time. The moon is after getting bigger. And look, it's full colours. That means it's daytime. We call this a waxing crescent when the moon is getting bigger. So again, it's a lovely, dark, moonless night. No moon on the nighttime side of the earth. Okay, so it just turned black and white. That means it's nighttime. So now we're seeing the moon during the nighttime. And it looks like a half moon, but we actually call it first quarter. The reason is the moon is now 1/4 of the way around its orbit of the earth. So this moon would appear just after sunset, because remember, it just turned from colour to black and white, that's sunset, and it would be very, very bright in the sky, and would then set about maybe 6 hours later as it moves across the sky. So as the moon keeps orbiting the earth, more and more of its daytime side will be visible as the month goes on. Here we can see it called waxing gibbous, so that's even more than first quarter. So the moon is getting fuller and fuller with every single day that we turn around. You can see the silver bit is getting bigger, the black bit is getting smaller. As more and more of the daytime side and less of the nighttime side of the moon is visible. So the earth keeps on rotating from day into night until finally we reach the peak of the month when we have the full moon. There isn't a single bit of the nighttime side of the moon visible. It's all the bright silver side. So at the moment the moon is only visible at night, and we're now past the full moon. So the moon is going to start getting smaller, or it's going to start waning. We're going to see a dark little sliver start to appear on the right hand side of the moon. And we call this waning gibbous. Not easy to see there, but as the moon keeps on going around the earth, we'll start to see that sliver getting bigger and bigger until the moon disappears entirely. It's black and white, it's nighttime again, and we'll start to see that dark part of the moon is getting even bigger. The silver bit or the bright bit is getting smaller with every single day that the moon goes around. And now we'll see that the moon is appearing in the daytime. It's all colour again. So the bright part continues to get smaller and smaller until we get to the point where the moon is half daytime and half nighttime and looks like a half moon, or it's actually called third quarter because it's 3/4 of the way around its orbit. So we get to see this lovely sight in the daytime just after dawn. And when the moon starts getting smaller than third quarter, we start calling it a waning crescent. It's getting smaller and it's a crescent shape. So with every day of the month, as we get closer and closer to the end of the 27.3 days, the sliver gets smaller and smaller. It's barely visible on the left now. Until finally we're back where we started, with the nighttime side of the moon facing us and the daytime side of the moon facing the sun. We can't see any moon at all, and we call this a new moon. Here's what it looks like when all the frames are cut together, zoomed in. So this is how the phases of the moon work, and you've just seen how it works. It's the rotation of the moon around the earth taking a month. Next time you see the sun and the moon in the sky at the same time, it's perfectly normal. In fact, it happens every single month. And now you know how to explain to somebody how it happens.